Hi folks, it's Dr. P. I'd like to discuss implementing if-then statements in Boolean algebra. They're really straightforward, but students tend to struggle with them because they don't contain the words and, or, and not. One example of an if-then statement is something like, if the button is pressed, then signal A should go to the output. Otherwise, the output should be 0. So every time we do Boolean algebra, remember, what we have to do is define the inputs and outputs and establish what is meant by a 0 versus a 1. Looking at this statement, we see that there are two inputs, the button and signal A. Then there's one output, which doesn't have any particular name to it. The button is probably just a simple push button. We need to figure out what a 0 or a 1 is. If you're using the push button PCBs that are available in lab, then this is already established. The way these buttons work is that when you push the button, you get a 1 as an output. If the button is not pushed, you get a 0 output. The signal A can be just any old signal. Maybe it's the output from some other logic chip. Maybe it's coming from a dip switch. Maybe it's a clock signal. I don't know, can be whatever. Here, it's not as important what a 0 or a 1 means when we want to interpret this Boolean expression. Okay, so let's look at the statement one more time. If the button is pressed, then signal A should go to the output. Otherwise, the output should be 0. Let's use a truth table to figure this out. One column of our truth table will be the push button value. Let's call it PB. One column will be A. The last column will be our output. Let's call it Z. There's two input variables, so there are 4 rows, or 4 possible values of the inputs. Now we need to figure out what the output will be for each row. This is where we need to really reread our expression. If the button is pushed, which we established means that PB equals 1, then Z will be equal to A. Okay, so when PB equals 1 and A equals 0, then Z equals 0. When PB equals 1 and A equals 1, then Z equals 1. That's not too bad. When the button is not pressed, we get a 0 output. This means that Z will be 0 anytime that PB equals 0. Let's find a minimum sum of products expression. We see that Z equals A and PB. This means that an if-then statement just becomes an and. When might this change? Well, if we had an opposite push button or an active low push button that says 0 when it's pressed, then I'd have a prime on my PB term. Or if I wanted to send A prime to the output, then I need to prime A. But even if I wind up priming a term, I'm still going to have an and expression. So next time you encounter an if-then, think about AND gates. And if you're still not really sure, just define your inputs and make a truth table. It works every time. Until next time, stay well.